According to Forbes, every minute users watch 4.15 million YouTube videos, send 456 tweets on Twitter, post more than 50,000 pictures on Instagram, and there are more than 500,000 comments posted and statuses uploaded on Facebook. Now, just imagine this huge chunk of data that is produced with such trivial day to day activities. And I still haven't counted our healthcare, security, and government data. This constant creation of data is leading to the formation of big data. Hi, all. I welcome you to this big data analytics session. And today we are going to analyze the impact of the lockdowns on COVID-19 cases across the world. Before we begin, let's look at our agenda for today. Now, this is a through and through hands-on demonstration. So first of all, we're going to analyze the impact of the lockdown imposed in various countries due to COVID-19, followed by performing ETL using Hadoop, Spark, MySQL, and Hive to understand how this lockdown helps to combat COVID-19. We are also going to compare this spread of the disease in India with other companies such as US and Italy, and finally determine the states of India in which the lockdown should be prolonged or extended. That was a fairly simple agenda. Do take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, if you want to learn about big data and other related concepts, do not forget to check out our training courses, the link to which I'll leave in the description box below. Also, this is a through and through hands-on video. If you want to give your big data basics a brush up, I shall also leave a tutorial link in the description along with the datasets and code that I will be using throughout the course of this session. So without much ado, let's get started. So let's get straight into it. Let's look at our problem statement. So I'm going to read it out for you guys. The risk of coronavirus is increasing daily, even after the government has taken several measures worldwide to minimize COVID-19 spread. Severity of the transmission chain is deemed to be broken only when no new case is reported in an area. The only way to break the transmission chain is to impose a lockdown. It was just a hypothesis at first. So let us examine whether imposing a lockdown was the right decision and how are we doing it. All right, so I hope this is a fairly self-explanatory problem statement. We are all by now, I hope, used to this self-quarantine social distancing norms. We're all staying home. Much of the stores, apart from essentials, are under lockdown. Our main objective here is to not feed new bodies to this virus to piggyback onto. Yes? Now, the objective of this whole exercise is going to be to find out just how effective the act of imposing a lockdown. So here are our problem statements. First of all, we are going to compare the trends in different countries which imposed complete lockdowns and restrictive measures. We are going to analyze the variation in the number of COVID-19 cases in these countries. Second, as we all know, the lockdown in the US happened quite late compared to other countries going through the same stage. And recently it has come off of most number of states in the US. So we are going to try to find out what could be the number of cases, the body count in US if the lockdown was implemented at an early stage like it was in Italy or South Korea. And finally, we are going to determine the Indian states where the lockdown must be continued. Now, for the demonstration purposes, I'm going to be using the Cloud Labs by Edureka, which is a feature you're entitled to if you have taken the Big Data course at Edureka. But you can go ahead and use your own VM to do the same. I'll be sharing the link of the VM in the description box below. So you can just go ahead, download it, and follow along later with this video.
to run the entire demo in your own peace and time. So let's move on to our first problem statement. Here we're going to compare the countries which imposed complete lockdowns and analyze the variation in the number of coronavirus cases. First of all, let's go ahead and look at our data set so that we get a better idea of what we are dealing with. So this is the data set we are going to be dealing with in this particular problem statement. It's a fairly simple data set. You have your dates, you have the name of your country, and the statistics regarding the number of individuals affected in that particular country on a certain date. Now this data set starts from the 22nd of January and is updated up to the 26th of April. So we have roughly 4 months of data, which is completely perfect for our kind of project, the one we are going to be doing right now. You have your confirmed cases, your recovery cases, and you also have the number of deceased individuals. So basically, this data set tracks the number of people affected by the COVID-19 worldwide, and you have fields which are the date, name of country, confirmed tested cases, recovered cases, as well as deceased cases. Now, the data flow diagram of this particular exercise is going to be something like this. So we have our data set in the CSV format. We are going to extract that data into a MySQL database, which is nothing but a relational database management system based on structured query language. This application is used for a wide range of purposes, including data warehousing, e-commerce, and logging applications. The most common use of it, however, is the purpose of a web database. Now we're going to read that data using Spark, which works with the system to distribute data across the cluster and parallel processing of this data. And then finally, we are going to use a web-based notebook known as Apache Zeppelin for our data exploration and visualization purposes. So with that, let's move on to our console, where we are going to move on with our first step, which is logging on to MySQL, creating a table, and loading our dataset into that table. So this is what my console looks like. I'm going to use this command to log into MySQL. Here on, you can use a /h to get general information and the list of all MySQL commands that you can use in your MariaDB. You can see a bunch of these commands right here. You can go ahead, take your time and use it. For now, we are going to move on with our demonstration. So first of all, we are going to create our database. So now I'm just doing this to show you guys how the command works, where in actuality, this database is already in use currently, and we are going to be using it for our project. Okay, so as you can see, it shows me an error. I cannot create this database because this database already exists. But we are going to very well be using this database. So I'm just going to use. Okay. So as you can see, you're prompted that your database has been changed. We are inside this particular database. So what we're going to do, we are going to be creating a table in here to which we can import our data set into. Okay. So let's call this table COVID details. Okay. And let's go ahead and enter a couple of columns in there. Yeah. So we have date, and what else? We have country, What else? We had three other columns, which were integer columns with the number of confirmed, recovered, and deceased cases, right? And then finally, we have our primary key, where our parameters are our dates and our country. Okay, so let me check if that's okay. That looks pretty okay. And now what we're going to do is we're going to load our data set into this table. So I'm just going to use now to obtain the location of where I have my file. I'm just going to open another one of these consoles, log in quickly. Okay, and use this to find out my location. All right, so let me just copy this location. And I'm going to put in the name of my file. We're going to enter our table here, our table name. That is our table name. Okay, so with that, we have imported our dataset into our table that we've just created. Now understand that this location is specific to where my dataset is saved. You have to replace it with the one where your dataset is saved, all right? You have to replace it basically with dataset path according to your system. All right. Now step 2 of this is going to be to log in with the Spark shell using the path of our MySQL connector. So let me just exit this particular instance. All right, it says bye, and now I'm just going to clear out this. Brilliant. So now again, I'm going to go to my other console, find out the path of my working directory. Okay, now inside my directory, as you can see, here are the 1, 2, 3 data sets, and here I also have my MySQL connector. So I'm just going to use pwd again so that I have the path. I can copy the path from here. So now let's log into our Spark shell, shall we? So we're using Spark 2 right here. Okay. It'll take a while. Kindly be patient. It's going to take a while before logging us in. All right. Now we have logged into Spark. We're going to then load it to Spark for further analysis. Also verifying if the data is loaded. All right. So this is what our data looks like. This only shows us the top 20 rows. Next, we're going to understand our schema for which we have to print our schema. This gives us our schema and the data types of the variables. Next, what we are doing is we are filtering out all the data that comes after 26th of March. Yeah, we're showing the top 1000 rows. And this will give you a fair idea of what the numbers are in the past 1 month or the last month of our data set. It's a fairly long table. Now, as our date column is of string type, it is bound to return you incorrect output. Hence, let's convert the string type data by adding a new column. For that, first we're going to create a view. And then add a date column, which is of date format. Now what we have to do is we have to verify if our new column has been added and is of data type date. So now we're going to try and fetch all the records after 26th March 2020. And now it gives us the expected results. If we go up, okay, let's go up. As you can see here, we have two different date columns. Now, based on this data, let's find out our top 5 countries. This is our result. Now we know that US, Spain, Italy, France, and Germany are our top 5 countries by number of confirmed cases. And that is the case till 26th of April 2020. So now let's go ahead and create a pivot table for better understanding of the increase in number of confirmed cases. All right, here's our pivot table. We have our dates in one column and we have all the counts from our top 5 countries in all the other columns. As you can see, the number growing with date. Now, using the standard scalar formula to understand the rate of increase of confirmed cases for all of these countries, we're going to add a new column called view scaled to store the calculated values. Here you can see mean and standard deviation of the confirmed cases from our data. And that we have our value scale data. Now let's filter our top 5 countries with their scaled values. Here are the top 100 rows of date, country, the stats of the cases, all 3 confirmed, recovered, and deceased from all our top 5 countries with their scale values. Now, our third step would be to open Zeppelin for a better understanding of our scale values. So let me just go ahead and log into Zeppelin. With that, I'm all signed in. Now you can use Zeppelin to create a table to visualize the data of your top 5 countries to understand the rise in their confirmed cases. As you all can see, after the lockdown has been imposed, there's a significant rise in the number of cases in all of these countries. You have US in purple, Spain in pink, Italy in green, Germany in orange, and France in blue.
If you compare just US and India on that particular day, US had 965,000 cases and India had nearly 28,000 cases. Moving on to our problem statement number 2, this again is using the data set I had previously shown. And our objective here is to find out what could probably be the number of cases in the US if their lockdown was implemented earlier than it actually was. Like I mentioned, we are using the same aggregated countries information CSV file. And just a quick reminder, that dataset tracks the number of people affected by COVID-19 worldwide and has the date, name of country, and the number of COVID positive cases, along with the number of recovered and deceased cases. Now, how this is going to work is that we are going to extract our data from our CSV file into our MySQL database and then analyze the data using Spark. It's a fairly straightforward exercise. So we have already created the table in problem statement number 1. We have already created the MySQL table that we required. And now we're just going to push for further analysis in Spark. So let's just get into our console, and I have already logged into the Spark shell using the path to our MySQL connector. All right. So first of all, we need to read our data and create a temporary view, again, which is named countries underscore aggregated. Now you can see right here that our date is in string format, which is why we have to convert the format into a standard date format so we get the appropriate values whenever we are using the dates in the table. Now what we have done is we have added one more column where the date is in fact in a date format, and we've named that column fdate, very similar to what we had done in the previous segment of this session. Now with this, we can take a look at our schema. We can look at all our rows and their formats in which they exist. We have 3 columns which are pure integer. We have 2 string and 1 date column. Yes, this is the one. Fdate or formatted date is the one we have just added. Now we need something using which we can further refine the partitioning, ordering, and frame boundaries. And for that, we are going to be using the window function. And we are going to order by confirmed cases and partition it by country. All right. The lag here basically returns the value of the column that is offset records before the current record. So assume yesterday's cases are 5 and today's cases are 10. A lag will return the previous record value, that is 5. So here are our top 20 rows. And with this, basically, we fixed the problem. Now what we're going to do is we're going to calculate the percentage of increase in the current day's confirmed cases with respect to the previous days. So it's a fairly simple formula. And now we can also calculate the cumulative percentage for the same. And here is our entire table with the cumulative percentage. You can see this for all of the countries. All right. Now, while comparing the confirmed cases of a country with respect to other countries, we need to consider the date when the confirmed cases are first considered. So that is going to be our day 1. Now, as COVID-19 spread in multiple countries on different occasions, the day 1 in India is not going to be the day 1 in the US or in China or in South Korea. Now, while comparing the confirmed cases in a certain country, you need to understand that the day 1s of each country are going to be different. The day that is day 1 in India is not the same in US or South Korea or China. So we need to fix our table. Now, the US government had announced its lockdown from the 1st of April. So what we're going to do is we're going to calculate the cumulative percentage in increase of the confirmed cases before 1st of April and on the 1st of April. Now, the US government had announced lockdown from the 1st of April 2020. And now what we're going to do is we're going to calculate the cumulative percentage in the increase of the confirmed cases. And we're going to do that before the date of 1st of April. All right. So this is our percentage. So the first figure is the one after the 1st of April, and the second one is before the 1st of April. And as you can see, there is a significant amount of decrease after the lockdown has been imposed. Now, as COVID-19 will be identified after 14 days of the spread of the virus, all the cases will be reported in the first 14 days. And that can be considered as the cases before lockdown. So if we try to find out the same things from, say, 15th of April, this is your figure. So we have our before and after 15th of April. You can see the significant amount of decrease in the number of affected cases. Now, don't worry if I'm going too fast or not typing out the commands. All the code that I'm using, I shall leave for you in the description box below. My team will be out there to help you through with finding the source material for all of this that I'm using, the data sets, the code, everything else. So don't worry, just try and understand the flow of this entire exercise through the course of this session. That'll be great. Later on, you can watch this video and follow along in your own time from your own place. So now what we are going to do is we are going to add the day number for India as well. Now, the Indian government had announced the lockdown from 24th of March 2020. So now we're going to do the same thing for India that we did for the US. We're going to calculate the cumulative percentage of increase of the confirmed cases before and after 24th of March 2020. And there we are. You can see
It's more than double, in fact, the difference between the two percentages. So before the 24th of March, we see the number is 993, and after we see it's come down to 430. May not be as significant as in the US, but one thing is for sure, it is working. With all the stringent rules and lockdown and self-quarantine, you can at least stay assured that we are on the right path by doing all of these things. Now, if we take the first 14 days like we did for our US case, again, you see a significant amount of difference, right? Okay. So now you can basically see the top 100 rows of our data from India. We have our day 1 to 88. We've basically filtered out the top 100, but since there isn't data for 100 days, this is our top 88 days. You can see the confirmed number of cases is quite consistent for the first couple of days, and then the number starts growing. And that is how pandemics work. It is a steady exponential rise. So it might seem like nobody is affected till one day you realize that everybody around you is actually affected. Once the number hits a significant threshold, it is just going to rise rapidly after. So now from the output, you can understand that India has announced lockdown on the 55th day and the US on the 71st day from the day one of spread of virus in the respective countries. Now, let us assume that if US had announced their lockdown, in fact, on the 55th day, which is during an early stage of the spread of the virus, there is a definite decrease in the percentage of the confirmed cases. So let us assume that US announced its lockdown, in fact, on day 55, which is a fairly earlier stage than when it did announce a lockdown. Now, it is obvious that there will be a decrease in the percentage of confirmed cases. But how much? Let's go ahead and calculate that. If you compare these two rows, which is the confirmed cases versus the assumption row, wherein the lockdown has been hypothetically imposed on the 55th day in US, you can see the difference in the numbers. It's in thousands. You can see on this particular day, on the final day, which is the 26th of April, the number from 965,765 would actually have been 871,969, which is a significant amount of people to save from this deadly virus. This is almost, say, 95,000 people saved. And with that, we come to the end of the second problem statement. Let's quit our Spark shell and clear our screens. Do stay tuned for the third and final bit of the problem statement, where we are going to try and fetch the list of Indian states where lockdowns should be continued. We are going to have a complete new set of data for the next problem, and also we are going to use Hive, HDFS, and Scoop for that part of the exercise. With that, I'm closing this segment. Thank you and have a great day.